So now that we've learned all of these exciting things about threads, let's kind of step back and put it all in perspective and evaluate the pros and cons of the different approaches we've looked at. And this will also give us a chance to look a little bit more detail at how the different implementations of those methods work for our GCD application. So here's one model. This is how you can provide code to a thread by extending the thread class directly. So here's the good thing about that. So here we have GCD thread that extends thread. You can see it's got an activity and so on here. So in this particular model, it's very straightforward. You've got the thread superclass. We just extend it. No muss, no fuss. All we have to do is override the run hook method. All the state and all the methods are consolidated in one place. So you can see here we have main activity. We can set that activity here, so it's all sort of bundled together and so on. And the nice thing about this is it allows us to do central allocation and management of the thread. So if you come down here, you can see we can say, make a new GCD thread, set the activity to this, start the thread. We can join with that thread, we can cancel that thread, and so on and so forth. So it's all very consolidated. This design turns out to be particularly useful if the thread has to be updated during runtime configuration changes. What is a runtime configuration change, you might ask? If you have an Android phone and you're holding it in portrait mode and then you turn it to its side and now it's in so-called landscape mode, that is what's called a runtime configuration change, and that requires tearing down the earlier activity for portrait mode display and replacing it with a new activity for landscape mode display. And you might want to update the state of a thread that's running across the runtime configuration change. And if you consolidate everything in this manner, it's much easier to do that kind of thing because it's in one place. So things like interrupting, restarting a running thread and reading and writing its state, that's all easier to do if you consolidate everything. And later on in the course, when we talk about managing the Java thread lifecycle, I'll talk about this in more detail. But of course, there's always downsides. You know, there's very hard to find one abstraction that's perfect for everything. So there are some downsides with extending thread. And the most obvious one is that a subclass must extend the thread superclass. And as you're probably aware in Java, a subclass can only have one superclass. Java does not support multiple inheritance of classes. It does support multiple inheritance of interfaces, but that's a slightly different issue. So in this case, thread is a class, and so by extending something, we basically have lost the opportunity to extend anything else. We're stuck with thread as our one and only superclass. So let's turn our attention to the alternative way to go. This is to implement Runnable, kind of see how this shakes out. So in this case, because Runnable is an interface, you can actually have a subclass, or rather a class, I guess in this case. Actually, this is a subclass. The GCD Runnable subclass implements multiple interfaces and extends one superclass. So by implementing Runnable, you leave yourself the flexibility to extend something else besides thread. And that could be useful. So in this case, we're extending the Runnable, the random superclass. Runnables are also more flexible because we can actually use them in other contexts. So they're not just limited to passing to the parameter of the thread constructor. And here's an example. We'll talk more about this example in detail later. But in this particular example, we have our GCD Runnable, which implements Runnable like we did here. And then we're going to make ourselves an instance of GCD Runnable, which we call Runnable command. And then we're going to go ahead and make something called a fixed size thread pool, which is a pool of threads with n threads. Let's say n is 4 or 8 or whatever. And then we can go ahead and execute that command. And this allows us to use that Runnable in more contexts than just passing it as a parameter to the thread constructor. So Runnable is more flexible, whereas extending the thread class binds you to the threading mechanism and a single thread. This gives us more flexibility. Of course, there are some downsides to using Runnable. They're more moving parts. What do I mean by that? Well, with runnables, you've got to make the runnable, and you've got to make the thread, or connect the runnable to some other execution engine like an executor framework instance. And now they're two things. So runnable and thread are separate entities, and they have to be accessed and managed separately. And this can get complicated if a program needs to access the state of a runnable but only holds a reference to the thread object. So now you have to keep track of more things if you want to do updates. Whereas if you do everything in a subclass of thread, it's all kind of combined together. As a general rule, which is always prone to exceptions if you know what you're doing, you can violate it if you're careful, most Java software, most Android software will implement runnable rather than extending thread. And that becomes even more true in the world of Java 8, where you're passing in Lambda expressions. So as you can see here, a very common thing to do is not to directly implement runnable at all, but instead to use Lambda syntax and just provide the computation you want to have performed and pass that as the constructor to the Java thread. So if you're using threads, this is a very common way to go. Now, having said all those things about threads, most developers in practice these days will be using other concurrency frameworks rather than working with threads directly. It's important to know how to use threads because it's a building block of concurrent programming, and so your first assignment will give you that experience, but you'll see after the first assignment, for assignments 2, 3, and 4, and so on, we move away from creating naked threads and use more powerful frameworks like the executor framework to do those things. So that's the end of the discussion of Java thread evaluation. So hopefully now you have a pretty good sense of the pros and cons of the different approaches. And these are all very good things to study for the first quiz, which comes up in a couple weeks, because we'll for sure cover some of the questions we discussed here.